Hi. All right. So the title, I spent a lot of time thinking about a title that would invoke some ideas into the head before I get into it. So keep thinking about it. I'm going to explain it later in the slides. All right. Oh, by the way, AirPow, I'm supposed to outreach AirPows. We got some booklet at our demo. So do get one of those. I don't want to take it back with me to NC State. All right, thank you. All right, so I guess I don't have to explain the telecom architecture to this audience. So we are going to talk about the RAN, or the radio access network. We have no business with UV or core in this talk, okay? So let's look at the history a little bit just to appreciate where we have come after 40 years of telecom evolution, right? So we started with this legacy RAN, all right, which was mostly deployed in 2G and 3G, probably still in 4G to some extent. And this is how it usually looks. I don't know if the image is nice. Gemini generated it for me, so please don't complain. So as you can see, it's proprietary, it's monolithic, and it's inflexible, right? I guess we all agree with that, right? There are only 3 vendors in the country, in the world. We don't talk about the fourth one. So they are very inflexible, right? If you buy an antenna from Ericsson, you have to buy everything else from Ericsson, right? So what we did with sRAN and vRAN, the Cloud RAN and the virtualized RAN, which I believe is mostly the case today, the good thing is now we have put some of our compute capability at some centralized cloud servers possibly, and these are how it possibly looks like. So here we try to solve some of the problems. Propriety, yes, is still there, but now we have disaggregated the RAN to some extent, the RRU and the BBU, and the best part is we softerize and virtualize to a great extent, right? Which I think was a really good thing to happen. And then flexibility is still not completely flexible, but we softerize this and virtualize this, and it definitely has improved, right? Then what happened? In 5G, at least in 2020, right, Open RAN happened, which had some success, right? There were some trial deployments, and I just read a news that 30,000 base stations are being deployed, which are ORAN compliant in Japan, if I'm not wrong, right? So which is good news, right? So here, what did we do? We opened the interfaces, right? So that was the issue with proprietary. We still had proprietary interfaces in the CRAN and VRAN. So we solved that problem at least, right? So softerize and virtualization we borrowed or we took from the previous generation. We disaggregated it a bit more, right? Now it's not just RRH and BBU. We further disaggregated the BBU into the DU and the CU, right? And then we made it open, great. Now the flexibility, I guess this is probably the best flexible system you can have. Some may argue, but I believe it's very flexible. And we introduce intelligence, right? So intelligence is not new to AI RAN, right? Open RAN was built on two principles, which is openness and intelligence. So we did introduce intelligence in Open RAN already, right? So here's a quick peek, if you're not aware of OpenRAN, which I don't think is the case, but a quick peek into this. OpenRAN, again, wanted to reshape the whole industry towards more intelligent, more open, and virtualization was already there, and fully interoperable so that they can probably bring down the cost. And for us, it was a really amazing architecture to work with to do innovations, right? The other stuff, I guess we all agree on that. And on top of that, the rig happened, which abstracted the entire network to us so that we don't need to worry about all these technical details of the RAN and just focus on innovation, right? Which was an amazing thing, I believe. And then we introduced R apps and X apps, and very recently the D apps, and some groups call it mu apps. It's not standardized yet, so I don't want to take a stand on each of these terminologies, but I see D apps getting much more used these days, right? And again, these X apps, D apps, and mu apps, these are supposed to be AI controllers that can control different aspects of RAN, right? And if you want to learn more, as you already know, you can go purchase the Open RAN book, The Fundamentals of Open RAN. All right, surprise, AI RAN happened just a couple of weeks ago, right? And seems like this is going to happen, right? With Open RAN, we still are skeptical. Um, but AI RAN, I think it kind of forced the entire telecom community to do something about it. Okay, it may so happen that not everybody will buy into this vision, but before we get into that, what is AI RAN, right? So it kind of borrowed everything that we had in Open RAN. Open, that's debatable, but disaggregated virtualization, software, and flexibility, amazing. What did they bring? They brought GPUs, right? At the RAN, right? At the lower layers of RAN. So what does that mean? It means I heard this term physical AI so much at Brooklyn 6G Summit, which I'm still trying to figure out why they call it physical AI. I believe it's probably getting way into the physical infrastructure at the edge servers. I think that's why they call it physical AI. But they kept calling physical AI. Okay. And then the mini data centers, right? So now our RAN is actually acting as a data center, not just as a communication infrastructure, right? Which I thought was an interesting thing. So now it brings versatility. It's not just about communications anymore. It's a lot more, right? Which I think is a really good thing that has happened to telecom industry in a very long time, right? So hopefully telecom is not going to die, okay? Telecom will be alive and it won't be nationalized. It will still be commercial. I hope so, at least with this new revenue model. All right. So why AI RAN, right? AI RAN, again, I'm still trying to figure this out, where the community is going to go. But seems like there is a lot of similarity or a lot of synergy between Open RAN and AI RAN. At least if you are familiar with AI RAN, right, they have these three kind of pillars, right? AI on RAN, AI and RAN, and AI for RAN, right? So if you see there, AI for RAN is completely borrowed from Open RAN, right? That's what we're doing in Open RAN. What it did was introduce these two new ideas, which is AI and RAN, which is that you can support AI applications right on the infrastructure in a way that Akamai business, right? Which runs this Netflix, deploys a lot of servers all around the world and then makes business out of that, right? So in a way, we are kind of getting into that space, right? Which is good. And then AI for RAN, which is the sensing and all that the team covered yesterday, right? So which is good. So we are sort of expanding Open RAN. So we can call it Open RAN plus plus or Open RAN star. So in a way, what is Open RAN? Open AI RAN. I think it's basically the same thing. It's just that they kind of took away the openness in the AI RAN. They make it, I guess they wanted to keep their vendors happy. So they said, okay, it's AI RAN. Now if you want to do open, it's up to you. If you don't want to do open, it's up to you. Okay? So again, OpenAI RAN is basically ORAN, okay? With these new capabilities of two additional AI, which is AI and RAN, and AI for RAN. If you don't agree with me, we can discuss more, but this is how I say it. So basically, with CRAN, with VRAN, and now AI RAN, I think we are potentially building the foundation of ORAN, okay? Do you agree? Yes, no, maybe? I think the answer is all of them. Okay, so depending upon who the commercial people are, who their applications are, who their users are, they might go one way or the other, or the hybrid of all of them, right? As of today, looks like Nokia and Nvidia are going to go the AI RAN way. Ericsson probably not, right? And I see why, right? The custom silicon, thing that you have, they are cost effective, they are fast, right? So that data centers can never do, right? So it makes sense. If you want to stay in the communication business, I don't see why you want to go with the mini data centers, right? But if you want to expand, then I see, yes, why you want to go to the mini data center vision. So again, it depends on where your priorities are, and then you can go one or the other way, right? So Open RAN is happening, okay? Open AI RAN is happening. And if you don't believe me, I think the AI RAN or the Nokia NVIDIA, I think is the lifeline to Open RAN. Okay, why? Nokia is itself a key player in ORAN. Nokia contributes 17% of all the ORAN specifications, Nokia was the first company who joined ORAN Alliance, and Nokia today is the external license leader in ORAN, right? So amongst all the vendors, Nokia is probably the best vendor when it comes to Open RAN, okay, or most, let's say, accessible vendor when it comes to Open RAN. NVIDIA, that's, I guess, the flag bearer of intelligence. Maybe they just want to sell GPUs, who knows, right? But I think it's a good thing that's happening to the telecom space. I think it will create a cascading positive effect on the acceleration of Open RAN or Open AI RAN, or at least some aspects of it. Again, why? Because what Open RAN was missing was value proposition. Okay? With Open AI RAN, now we are kind of closing or answering that question that where is the money? Okay? My dean always says when I go with some ideas, you're like, where's the money? Okay. So again, we can get motivation from other fields, relevant fields like computers, or SDNs, right? And now today is the cellular RAN. We see a very similar trend. Okay, so in early 1980s, when computers started opening up with the interfaces. So before that, we used to have mainframes, right, which used to be a big closed proprietary box, like today's legacy RAN in a way, right? But then, these two guys came up with the idea of opening it up. We said, okay, we will have operating system, and then we'll have interfaces, proprietary or not, and then we'll open up the software layer or the application layer where everybody can innovate and see where the computers are today, right? At a time, IBM said that there will only be 15 computers in the entire world. Today, every person potentially have 5 to 10 computers with them. They don't realize. Their watches are computers, their phones are computers, their refries are computers. Everything is a computer today. Okay? So I'm not saying we'll have similar kind of impact with Open RAN because our community is much smaller, but we are going the same paradigm shift, going through the same paradigm shift, and there is no turning back. Okay, the same thing happened with software-defined networking or the internet, right? Before SDN happened, we used to have these routers where we'll implement all the routing algorithm, and if you wanted something more, you have to have middle boxes and deploy it somewhere in the internet, right? That was not very sustainable. So we said, okay, let's open it up. Let's have very, very dumb routers which only does switching. Take the data, give the data, right? Input and output put. That's it. And everything else, all the intelligence will be implemented in the software, in the virtualization platform, right? So that's exactly what we're doing with Open RAN, right? We're saying, okay, our RAN would be very, very dumb, hopefully, the RUs and the antennas, and everything else will be on the software, will be on the cloud, right? Which I think is exactly equivalent to what happened to STN and computers, right? So they haven't gone back. I don't think we are going to go back. But similar to computers, where we have Mac OS built on open source operating system, we have Windows completely proprietary, and we have Linux completely open source. Maybe we'll see similar business models in Open RAN. Okay, so there might be Ericsson, no, no servers, maybe completely proprietary interfaces. There may be Nokia who does some or built on open Okudu effort maybe, and then build something proprietary, and then private 5G or srsRAN will have a completely open source software. Who knows, right? We'll see. And I truly believe that Okudu will have a big role to play. Okay. So again, with all this, I think Open AI RAN is going to happen. It's just a matter of time. All right, so with that in mind, now we understand that OpenAI RAN is nothing but ORAN++ or ORAN star star. Let's see what are the R&D areas that we should be looking. Again, this is my personal bias from my own understanding. So we obviously started with AI or applications, right? And there are very good reasons for it. There is AI RAN, there is NVIDIA Nokia partnership that is kind of making this a really hot topic. Again, at Brooklyn 6G Summit, they were like, after years, telecom has become hot again. And then there is all these funding opportunities when it comes to applications and AI, right? So I think those are potentially the drivers for a good interest in AI and application in OpenAI RAN. The second one is the testing, right? Because you have now broken down all these different components and trying to get vendor A's CU and then vendor B's DU, which I think should have been a part of Okudu, right? srsRAN should not have been building all the platform. It should be given, CU should be given to OAI and DU should be given to srsRAN maybe, and then let them interoperate, let them figure out how it's gonna work. But anyway, so I think testing becomes really, really important, right? The interoperability between these different components becomes really critical, which wasn't the case in the previous generation because Ericsson would build everything for you. So they will do all the testing for their hardware. And then ORU is a big part. I see a lot of interest, particularly because of NO42, I think. And the last piece is ORAN automation. I think that is really, really key, right? Somebody needs to integrate vendor A, RU, vendor B, DU, vendor C, CU, vendor D, near real-time week, vendor E, SMO, and vendor G, whatever. That's a huge effort. So who is gonna do it, and how much time would it gonna take? If it's gonna take 6 months, nobody's gonna do it, right? If you look at this 2022, this AT&T, right? They did this bill, they did this deal with Ericsson that they're going to move to Ericsson. They made sure that they do an ORAN compliant bill with Ericsson, right? But they went with one vendor, right? And I think the issue was the integration. So if until and unless we solve that integration automation issue, that will inhibit the adoption of ORAN. So with that, now when it comes to applications, right, from lab to field, I see in the field or the industry, RAPS is taking the center stage, right? And if you don't believe me, look at this report. More than, I think, 80 or 90%, they are more interested in RF. And I see why, because because it's much slower system. You have the time to fix the problem if something goes wrong, right? It's less, what's the word? Sorry? Yeah, I mean, exactly. It's less risky. Let's put it that way, right? XApp is very interesting. That's why I think academia or the labs are interested. But the problem is if something goes wrong, you have less than a second to fix it, right? Until and unless, telecom operators trust your XApp, they are not going to deploy, right? Because at the end of the day, it's their business which is getting hampered, right? So we have developed some of them. Here is a couple of XFs and RFs that we have developed, all the way from interference classification and mitigation XApp to radar detection XApp to Spark. Impact we demonstrated at the RIG forum. And in fact, as a part of Impact XApp, we did the traffic classification using some machine learning models. So we were able to classify with about 85, 90% accuracy just based on KPIs collected over E2 interface between the URL, CMBB, and MMTC. We have also integrated this millimeter wave beam switching XApp. We are working. We have some prototype with UE positioning and others, but they are not published yet. So maybe a quick rundown on Spark. We do have some time. So here is what Spark does, just to give an idea how these applications could really move the telecom field forward and could solve some of the really important problem. At least that's how I feel. So here the problem is that imagine a private 5G deployment, right? And then usually for private 5G in this country, we consider CBRS, right? So usually the PAL license we have for CBRS is for 20 megahertz or 40 megahertz, right? So that's not a lot of bandwidth. So if you want to deploy multiple RUs, right? Because obviously there are multiple users, it might be a decent size private 5G network. So in that case, if you simply partition those RUs to work on different part of the band, let's say give 5 megahertz to each of them or 10 megahertz to each of them, that's already reducing a lot of capacity that you're already strained on, right? So what we wanted to do was, can we use entire band at all the RUs at the same time, right? That's what we wanted to solve. So for that problem, we thought this Open RAN could really help. So how? We want to do the dense deployment so that we can have better SNR, we can support more capacity, more users, and then we use this Open RAN system, which I'm going to show in a minute, to intelligently allocate the spectrum at different sites based on the traffic demand and the channel conditions. Okay? So if there are some interference in the environment, we try to address them as well. So this is how it works. So on the top, we have this XApp, which detects and localizes the interference in the band, and then we try not to use those resources at that particular site. Okay, and then at the site, we allocate resources based on the traffic and the available resources at that particular site. And for that, we use a Mu app. We worked with UC San Diego to use their real-time rig or ASIC, and I'll show you how it works. So here, look at this spectrum. So this is the entire available spectrum, for example, and let's assume that at one site, there is an interference at the lower part of the band, and on the other side, we have, let's say, some kind of interference going on in the upper part of the band. So we basically use XApp to localize those interference, okay? So once you have localized those interference, then what you do, you redistribute the spectrum across these two sites so that they can all use the entire band. Okay? So here is the overall system based on srsRAN, as you can see. And then we have this, this Mu app over here. Maybe I can use the pane. So here we have this RB blanking Mu app, which works in the real time. And then this is the real-time E2 agent. And then on this side, we have the interference detection and localization XApp. Okay? So overall, we got a pretty good latency. For the real time, we got about 800 milliseconds. And the reason was we needed spectrograms, and that takes a lot of time. And on the real-time rig, we get less than a millisecond, actually as low as 90 microseconds. So it was super fast. And we got some really good performance, otherwise I would not be presenting here, compared to the baselines. But let me show you a quick demo. So this is a system, we deployed it in our lab. So here in the first part of the demo, we are basically showing, let's say, one RAN site. So as you can see, there are these two RAN sites, and they were literally deployed like this. There were two tables. We have one RAN site here, and we have RAN site over here. And then they both operate on the same frequency at the same time. And then we introduce interferer using GNU radio-based or a MATLAB-based, GNU radio-based interferer, which basically sends signal through a USRP B210. So as you can see here, we are trying to show that how we detect the interferer. And then once we detect the interferer, we blank those resource blocks so that you are not using them at that particular site. Now we are going to show this multiple site. And as I said, we look at the interferer, we look at the load, and as you can see, we give more resources on the fly to site one because there is more load. Now we're going to change the load at some point. As you can see here, we now have similar load, so you can see the spectrum redistribution has changed to almost equal. And then we give more load to site two and then less load to site one, and then you see how things are changing. Right? So this is all possible because we have Open RAN, we have DApp, we have XApp, right? So I think it's a really good use case of Open RAN. Here, one of the problem is how do you build this best machine learning model, right? Machine learning is everywhere. In fact, in this work, we use machine learning, right? But we are not machine learning experts, right? We do a lot of guesswork, a lot of grunt work, right? In fact, this student, they spend months on building machine learning model for the XApp, the interference classification and localization. And then we have another model for the RB blanking, right? So it takes several months. So we wanted to solve this problem. So what we did, we developed something called NeuralSmith. And this is a part of my company. So here we say that machine learning made accessible for all. So here we allow data engineering. You basically have to upload a data set. We do the data engineering for you. We select the features for you. And once you have done the data engineering, we also help build the optimal models for you. You can converse with NeuralSmith if you don't like something about the model that we have generated or the data engineering that we have done for you. You may want to interact with the NeuralSmith and get that result. And It's a very simplified process. You basically upload the data set and you get a machine learning model in minutes. It's fully interactive. You can interact with the user-friendly conversation. And the good part is it's built as a plugin on VS Code, so your data never leaves your machine. And we have benchmarked on MLE Benchlight. We are always within top 2% of the best ML models. And we also benchmarked with the wireless data set. And as you can see here, we actually outperform the best model out there. So it looks like wireless people are not really ML experts. And the good part is we do it in seconds and minutes. Assuming, so what we do, we also look at your system, what kind of RAM you have, how many cores do you have the GPUs. So depending on that, we try to use all the resources to train your model on the fly. So as you can see, probably the last one, when you don't have a GPU, it takes about 1.6 hours. But if you have the GPU, it gets done within 10 minutes. So if you want to check out the demo which on this corner of this floor, you can do that. All right. So now let me talk about AI 5D test. So here, like I mentioned, the integration testing is really, really critical, right? So ORAN testing, particularly IoT doesn't stand for Internet of Things, it stands for interoperability. That's a must, right? I mean, other testings are also a must, but they are also relevant to existing systems, right? The performance, the end-to-end, and compliance, they're still let's say, applicable to the existing system. But with ORAN, interoperability becomes a really important challenge. And the problem is that for testing, you have to cross-reference across multiple documents, which are in thousands, right? So if you look at 3GPP specifications, it's about 14,800 each document. And in ORAN, we have about 150 each document. And most of the times they are fragmented, incomplete, and even if you get the specification, they are prone to human interpretations, right? So today, if you look at the OTIC or the TNE center, they always manually run this test. So what they do is capture the packet files, they check the signaling messages, and it can easily take weeks to months. So basically, the state-of-the-art approach for testing is time-consuming, prone to human error. We need to solve this. So we were awarded by NTI NOFO 1, where we promised to solve this problem. So we have the first version of AI 5G test. It automates a lot of this. So it automates the generation of test procedure, which would take an engineer with 30 years plus experience, several hours. We do this in half a second. Then we automate the validation of the signaling messages in 3 minutes. And finally, if something goes wrong, then we identify what went wrong. And that takes about 40 minutes. So let's quickly review how the testing looks like so that you are on the same page with me to understand the testing automation piece. So the way it usually works is that you need to go load a test case, right? Whether it's the ORAN specifications from some group like TIFG or Working Group 5 or wherever you get the wherever you can find the test case. Or it could be a 3GPP test case, right? So once you have the test case in mind, now you need to go extract the test procedure for that given test case, right? So for that, you may have to reference the ORAN specs or 3GPP specs, and at times you might have to look at HC and ITU and other documents, right? So once you have the specifications or the test procedure, then you need to collect the logs for the device under test. Let's say you're looking at DUCU interoperability test, right? So you have to go find the PCAPs, the logs relevant to that particular test case. So now you have the test procedure and you have the logs, right? So now you need to do the comparison, right? That did my system followed what the specs said, right? So that's how testing works. So as of now, it's fully manual. With AI 5D test, so what we do here is, so here on the top, we have the test case repository. So that's where we go and read the test case from. And we have tried out interoperability, functional end-to-end. I don't see why it will not work for other test families like security and others, but these were the test cases that we could run on srsRAN. And then on the bottom, we have the system under test or device under test. So because it's srsRAN, there is no ORU as such, which is disaggregated today. So our testing is limited, or our device under test is limited to CDU interoperability and core and RAN end-to-end. So here now we retrieve the test case, whatever test case you want to test. And what we do, we have this generator LLM, which is actually based on this custom LLM tool that we have developed. It's called ORAN-Site. I'll give a little primer on that in a few seconds. So this Gen LLM is fully educated on 3GPP specs, on ORAN specs. So what it does, it looks at the test case and it gives you the expected procedure automatically, okay? Now, this automation isn't 100% accurate at all times. So for that reason, we introduce a tester in the loop who we don't ask them to go look at all the specs. We give them the top K most relevant specs to validate and approve that the test case or the test procedure is accurate. Now, this one is 100% accurate on the test cases that we have tried, okay? So once you have the test procedure, on the bottom, we collect the PCAPs. We do not use the default srsRAN logs because it does not have all the information we want for the evaluation of our testing, and it has a lot more unnecessary information that we don't want, right? So it was becoming a big problem. We said, okay, let's not do that anymore. So what we did, we developed our own PCAP analyzer, which is based on Wireshark, and using that, we only collect the PCAPs and logs that's relevant for that particular test case. So it makes our life so much easier for validation. So in validation, we use this val LLM or the validator LLM. So it basically tells me whether the system under test has passed the test procedure or not. If yes, then your job is done. You get a summary. If not, then we trigger a debugger LLM, which goes and debug each and every procedure step and figures out where did testing go wrong, what happened, where did the system go wrong, okay? So let me show you some examples. So before that, let me give you a quick primer of ORAN-Site. So like I said, Gen LLM or the generator LLM is built on ORAN-Site. This ORAN-Site is built on open source models like Mistral, Queen, Llama, Phi, and Gemma, all the way from 1 billion to 70 billion. We could not do more because we don't have the GPU resources to do more. But anyway, we do pretty well, actually. We had to develop our own fine-tuning framework called RAN struct because the existing fine-tuning framework did not work well. And as you can see, we use or we feed ORAN-Site or we fine-tune ORAN-Site with ORAN specs. At that time, it was 116 documents. It's about a year old. And then we had the 3GPP specs, and we also actually fine-tuned with srsRAN. So you can actually use this tool to ask questions about srsRAN code bases. You can't generate code yet. That is something we're still working on. But you can ask questions about different parameters, different modules, and so on. OAI, we haven't done it yet. That's on our pipeline, but we don't see how we can publish a new paper. So we're putting it on a hold for now. And then ORAN-Site reasoning will be available very soon. It's kind of complete now, so we are going to make that available very soon. All right. So here is a little benchmarking. So as you can see, we have these two different benchmark data set, the ORAN bench, which is built on ORAN specs, and then srsRAN bench, which is based on srsRAN code files. So as you can see here, at some version of ORAN-Site, we do beat some of the baseline or some of the best baseline models there, which is not expected, which is kind of expected because ours is a more fine-tuned model. But the better thing is we also beat all the telco LLM models out there, whether it's Tele LLM, probably from Yale, TSpec LLM from Khalifa, if I'm not wrong, and NVIDIA ORAN from NVIDIA, obviously. So we beat all of them by significant percent. Here's a quick demo of them, but it's not available because it costs money and we don't have the money to keep paying for the tokens. But the models are available on Hugging Face. So if you want to try it out, you can just download and use it. So this is the one where we are showing that you can ask anything about ORAN specs. The second one is where you can ask anything about C plus of srsRAN code. We also try to generate code, but like I said, it's not very accurate. That is something we're still working on to make it more accurate. And the last piece is that we also let people upload ORAN or 3GPP images, and you can ask questions about them. So here we use a combination of the ORAN side who understands the data specs and vision model who understands the image. Now you can ask any jargon from ORAN or 3GPP, and you'll get a pretty good answer because it understands that. So let me give you a quick test case going back to AI 5D test. So let's look at this very simple functional test case called UV initial attach. So as you can see, it has about 18 steps for this particular test case. So basically, for the system to pass this test case, we must follow these 18 steps in the exact order with the same protocol, with the same message and everything, right? With the same endpoints. So the Gen LLM, like I said, we also give you the top key documents. In this case, the first document itself has the information. So which is this? If you go and open the document, you'll see that this is here. And then it also gives you the exact procedure. So in this case, it is very accurate, but like I said, it's not always that accurate. Let's look at another one, for example, registration of single EMBB network slice. So here the test case generation was not very accurate, so I'm not showing that. But the retrieve document, if you go in there and see, you will be able to find it. And this is another reason why GenLLM is not always accurate. The reason is that this test procedure do not come in one form and shape, right? Sometimes it comes in a table, sometimes it's a picture, it's a diagram, sometimes it's a little paragraph. So it kind of is not that easy to do. But again, it's not too bad either. I'll show you some results. And these are all the test cases we tried out because these were the only test cases we could run with srsRAN. So as you can see, it goes from CUD interoperability to this, let's say EPC, G-Node B use cases, the functional, or let's say the core and the 5G Node B, right? So these are the different test cases we tried out. So when we compare GenLLM, the automated generation of test procedure, to, let's say, GPT and Gemini, we do beat them. So here the metric we use is called Gemini score. So this basically kind of captures how semantically similar you are to the ground truth, okay? So this can never be zero, right? I mean, even I speak two sentences twice, I won't be using the same letters and characters, right? So it's never gonna be zero. But as long as it's below 10 or so, it means you are very, very close. So as you can see in our case, we are kind of there, but we do not go beyond 20. Beyond 20 means you did not really understood anything. You just understood English in a way, right? So we are not too bad. We are around 12, so it means we are very, very close, but there is still room for improvement. So here's a little demo of the Gen LLM, and again, it's here if you wanna go check it out. So here we are showing that we have some pre-populated test repository, some test cases. So in here you select whatever test case you want, and then at the bottom you click on the generate with Gen LLM. You have the test case, and now you can see that we format the test case a little bit because we want our Gen LLM to have the best prompt possible, and then it goes and does its job, and you'll see in a couple of seconds, not a couple of seconds, in a couple of milliseconds, that it will come there. No, it actually is taking, yeah, okay. So now you see that the test procedure is coming up. And then once the test procedure is up, we also give the top 5 document. You can go check manually if you want. All right, so I will, maybe we can wait. It's not gonna take a long time. So this was the UE initial access. So as you can see, these are all the steps there. Yeah, And then on the right, you have the top 5 documents. And once you click on that document, you will see on the bottom, you see the exact uh, procedure from the specifications. All right. So that's the generated LLM part. For the val LLM, this is, let's say, another test case that we are showing, and this is a true positive. So this is where everything went really well. The system under test did meet the testing of that particular test case. But when it fails, so in this case, for example, so it was following the procedure, but after state 10, it did not, right? So that's where the val LLM triggers the debugger LLM, and now the debugger LLM trying to figure out what is going wrong. So here are some quick results on some of the failures. So for example, these have passed, so we don't need to trigger the debug LLM because this has already passed. But when it fails, for example, these are failing, or let's say these are failing, then we kind of trigger the debugger LLM and it kind of tells you what's going wrong. Like some messages are missing or some steps were wrongly executed or whatever, right? And here is a little demo of LLM. Again, it doesn't take a long time. Maybe I'll just go and show you. So here we basically get the we get the PCAPs from the system under test, which is over here. And once we have the PCAPs, then we start comparing whether the system under test is meeting the procedure or not. So in here, for example, at some point you'll see that okay, we are meeting the procedure, and then we keep going. So overall, like I said, for each test case, generated LLM is about 33 seconds. The val LLM is 3 minutes, and debug LLM is about 41, 42 minutes. So basically, the val and the gen is like few minutes, whereas with debugging it's about 45 or so minutes. And manually, I think it takes much more than 15 hours. But this is the only reference we could find. So basically, AI 5D test, it's an AI-powered specification-aware testing framework that automates the flow generation, the signal validation, and debugging. We do reduce manual effort significantly, and we are currently in the process of integrating this with Orchid. We are also in discussion with Valor to integrate AI 5D tests into their ecosystem. And this is all done by my awesome Nextg lab, so kudos to them and my collaborators, obviously. So here are some concluding remarks. So OpenAI RAN is already happening. I don't think there is a doubt in that. Things do look uncertain or chaotic right now, but I think it's a good chaos, right? It takes time, right? Before everything settles, the Brownian theory, right? And from lab validation to field trials, I think this will all contribute to the success of OpenAI RAN or ORAN. And again, similar to Linux, Android, I think OpenAI RAN will thrive, right? Linux took 30 years. OpenAI RAN probably will not take 30 years, hopefully. And people like us, the university labs, the small vendors, the hobbyists, the government, right? They are the one who can really accelerate this. And as I commented yesterday, right, we need to find a new market so that we can survive for a little while before we thrive. And this is my take on this. The way operating system transform the entire computer world, I think OpenAI RAN will transform the cellular network. So basically, once we have Open RAN, until and unless we are making some innovation in the hardware or the antennas, it might just be software update. That's amazing, right? We can have software update every month. So we'll not be waiting for 6G for 10 years. So here are some last um, taking points, right? I think team also covered this. The software is eating the world. I'm not saying this. Mark Anderson with Washington Journal said this. I'm going to add on this. AI is eating the software, and software is eating the world, so AI is eating the world. So OpenAI RAN, which has software and AI, is eating the telecom world, and it just seems to be a matter of time before it becomes a reality. Questions? Thank you. Yes.
Yeah, I saw the demo, especially on the testing piece side, seems something that is highly relevant to what we're trying to do with Okudu and making it relevant to the telecom industry. Have you had any traction with any of the MNOs or vendors that, my understanding is the testing that they do in-house is a huge, tent pole for them, with their adoption of this tool. And then what's the next step? What are the discussions with Orchid and Valor for integrating it?
Yeah. So what I'm trying to do right now is work with this TNE centers and see whether it works seamlessly in their ecosystem with commercial hardware, right? Or commercial DUs and CUs. And if it does, great. If it does not, then we want to see what are the additional development that we might have to do to make it work. So that is the whole reason why we want to integrate with Orchid. And we're working very closely. They are making us work really hard to sort of replicate what we have in their ecosystem. I'm like, man, this is not research, but but if you want to demonstrate something, you have to do that additional work. So we are working with that. Yeah. With Valor, they are still trying to buy GPUs. I saw Valor person here. For last 2 months, they're still buying GPU to run our LLM model. So once they get the GPU, then we will start the process of integrating. Okay. Any other questions? Yes, sir.
Yeah. So our engineers have actually had a lot of fun trying to use AI to sort through standards documents, just kind of like you were doing. Have you compared this to some of the commercial offerings like Link AI, LANC? Is that
Compared with what?
So the ability to like upload a standards document, thousands of pages of standards document, to load your tokens in context windows. Have you compared what you've done with the 5G test infrastructure, processing those large documents, to some of the commercial offerings?
Yeah, we tried to do that with Val LLM. It did not work. So we build a wrapper around it. We still use Llama 70 billion for Val LLM. We did not see a value on why we should fine tune because at the end of the day, it's log analysis. So it works really well. It's just that its context length is so small and the log file is so big that it doesn't understand or doesn't ingest at the same time. So we build a wrapper around it to make sure that we give a partition of the document and it still maintains the flow that we want. Yeah, so it's actually open source if you want to try it out.
No, I'm interested. I'm curious how that compares to some other offerings. There's a couple of startups. We'll talk offline.
Sure.
That are trying to tackle that one too.
Sure, thanks. All right, if no more questions, let's have lunch.